Hello, I'm Ellie. I would like to look at the causality component of the responsible AI dashboard that comes with the Azure Machine Learning. So I will start off by talking a little bit about causality, not a deep dive. I really love the concept. And then I'll show what I've done as an example to use it and how to interpret the results. I will rant a little bit. So, causality analysis comes to answer questions like the why questions. So usually, when I started doing statistics, I was told you can ask the where, when, what, how much, who, but you can't ask why. And then I came across this paradigm of causality analysis, started off by Yuda Perel's book, Why? And my eyes were opened to the ability to start the framework that allows me to ask these questions also when we don't have a structured experiment. So, would sending an email drive more sales? Does being a woman cause a reduction in probability of being hired? Does eating chocolate increase the probability of winning a Nobel? These are questions about what is driving something else. So cause and effect. And you can see that one of the questions here could be related to the discussion around ethical AI, responsible AI, and so forth. So here's a way to look at it. You, a person or expert about your world, have an hypothesis. You will want to use statistical modeling to test that hypothesis. Usually, we say that the gold standard is randomized controlled trials. We might want to do the statistical modeling rather than handcrafted, use it with some data mining that is kind towards automatic particle identification and the link between a human coming up with the hypothesis and the machine automation things is augmented intelligence. And actually using the randomized control trial to identify what is causing what gives you that causality paradigm. So causality is part of statistical modeling and a link between what you believe and what the data tells you. But Yuda Perel and others have come up and said, look, what do we do when we don't have the randomized control trials and we have data about the world that somebody has collected? So they came up with a whole set of mathematics and a philosophy of how to actually try to identify that causality structure without a randomized control trial, the best as you can, of course. And now the modern, when I started looking at it, it was let's handcraft those beliefs in a particular way. But now there's a new world of also let's try and identify those causality patterns automatically. It's causality discovery. So just to help you think about this, you could say that I observe that when I go to sleep with my shoes on, I wake up with a headache in the morning. That's a direct causation, right? Each time I fall asleep with my shoes on, have a headache in the morning. Now, there's a confounding effect there, right? I usually go to sleep with my shoes on because somebody forced me to drink too much, and therefore also I've got the headache, and it's not a direct effect, but an indirect effect. There's another confounding factor that is affecting this. Now, imagine you build a statistical model not knowing that particular confounding factor causes you to come up with wrong modeling. Here, I'll give you an example. If you've got a gene and you would like to, and you observe that the levels of activity of this gene on a particular outcome, and somebody asks you, what happens if this gene does not exist? So it's, oh, no problem, I'll do a regression line and it will be somewhere here. But, see, you can do a confidence interval. Now, if this gene is actually affected by a confounding effect, right? So there's a confounder that affects both the existence and non-existence of gene B and of the result. So what happens is that just continuing this just naively is wrong, because actually your prediction should be it's still within the range of the observations that I see, because it's to do with when I see gene B. If I don't see it, it's to do with the confounder, not with the gene. So if you get the causation, a better understanding of the causation structure of the system, you can do better modeling. So it's definitely an important paradigm to know. And of course, you can quickly imagine how this could be relevant also to doing responsible AI. So if the confounder is gender, you do definitely need to have the ability to ask that question. So a causal graph is an important tool in causality analysis. Directed graph that says, okay, the customer age will affect, you look at it and you immediately know what it's saying, that the mathematical structures of how these things are affecting each other is the interesting bit. But if you look at this graph and say, okay, customer age affects both education and the income impacts something that's about high limit that is given to a particular customer, and whether they have it or don't have it together with the income affects whether they will churn. There's also a lot of other unobserved variables that we don't know about. But if you make a few assumptions about how these are affecting or in a particular way, then you can start building a model. Now, if I look at this model now and I say, hey, look, really what I need to do is give me the income, give me the high limit. That's all I need really to predict the churn. I don't need all these other variables that will actually, if I put them into a regression, for instance, they will cause the estimates to be wrong. And if I put it into a random forest, it will cause maybe a overfitting that is not what I would like to do. But I can start, even if I model the full structure here, I can start asking questions of what would happen if I were not at the age that I am. Let's say I was younger by half. Now you can see here, rather than just putting a different age here and in a regression, I would say, oh no, it's not only that I changed the age, I will have to change something about the education because it's likely I have a different level of education, different level of income, yada, yada, yada. So it's changing here will affect indirectly all the other elements within the graph to predict the target variable. Microsoft and Amazon have identified that this is a very, very important field to be in, and they've come up with a few open source packages. One of them is called DoY, PyY, and this is an announcement where they started collaborating on that. The PyY package is a package I strongly recommend you looking at. It's got both the classical way of assessing a directed graph, and it also includes now the ability to do causal discovery. So that's about causality. Now let's look at what Azure Machine Learning gives us within the Responsible AI dashboard. I do believe it has a place within uh, the discussion around the responsible AI, ethical AI. It's to do about the interpretability, the explainability, the model building correctly, ensuring, to an extent, there's also an element of ensuring fairness, as you heard me mentioning before. So I decided, that I was bored with the data set I was using in the previous videos, that I wanted a new one. Not 100% sure it's the best one to show all the features of the dashboard, but it did interest me. When I was looking, I wanted something that not many other people were using in their videos, and that did interest me on other aspects. So I took it. I took the CDC places database that gives you per location some prevalence variables about health outcomes, activities around health prevention, health status, risk behaviors, disabilities, and social determination. For instance, on the risk behaviors, you'll have the percent of people that report that are most likely or report binge drinking, the percent of people who are heavy smokers, adults or heavy smokers, and percent of people are not doing physical exercise in leisure time or don't get much sleep. Of course, this is estimates and built in, and they sometimes there's two types of variables there. One of them is the direct percentage, and one of them is age corrected. And I was interested in some of the outcomes, mainly in stroke. And I'll admit, I am a significant proponent of banning smoking totally. And I was interested to see if one can suggest for the data here that if you reduce smoking significantly in the population, then that the expected effect of stroke will be seen. So first of all, I've created an ML table data asset where I split obviously between train and test, like in the other videos. This is kind of following the same examples that come from Microsoft. I created a logistic regression, straightforward logistic regression, and you can see here the performance, the metrics are not amazing. Actually, very, very not amazing, and there's a good reason for that. And then there's the low correlations in the data. But for the demo, this is sufficient. And then you just say, okay, I would like the responsible AI dashboard, please generate it. And this time, not like in the previous videos where I focused only on the error analysis, I added also here the causal widget and counterfactual. And I said, okay, I'll do also the explanation. But you know exactly what to expect with the explanation. So this is the full gamut of all the different widgets that you can, or components that you can add to the dashboard itself. So if I want to see the dashboard, there's many other ways of getting at it, but this is the easiest way for when I do it automatically this way is in the overview, I just hit the open and the new components that I get now that we're talking about are, of course, feature importance. Makes no. Maybe I should show you. My target variable is the stroke age adjusted. I have in my code the ability to exclude some variables. What I've figured out is it's better to create the data asset itself without those variables. Otherwise, the pipeline breaks later on. These are the variables that I tell the causality analysis to look at mainly for the treatments. So you'll see here the smoking and the sleep deprivation and physical activity. And then I load in my two ML tables, and the pipeline itself looks like, okay, here we are, I use my linear regression component. You can see that I've also did a causal discovery component for later on, but it doesn't affect it doesn't impact this is my calculation using do-I. And then I do, construct the responsible AI and then do the different components and then collect them exactly like in the example that they give. So if I go back to the dashboard, these are the variables that come in most predictive or have the highest contribution to the model. You get the counterfactuals and you got the causal analysis. which to my mind, the causal analysis comes before the counterfactuals. And you have within the causal analysis, they explain what it is about. If I click on this, it will say, oh, it answers the what if question. No, the what if question is the counterfactual. The causal analysis is looking at the impact of particular variable on other variables. I do try to write here what are the ways that they kind of assess it. It says here that Lasso regression was fit or to predict Y from X not including this observation and X including this observation. So there isn't, to an extent, an attempt to in what's called the two-stage causality analysis, kind of what happens if it's 0, what happens if it's 1, what happens if this value, that value. By using my model and trying to use my predictions to see what will happen if I change something within a particular variant in a univariate way without considering how it will affect the other variables. You got here the effect estimates for each one of the variables. You can see that the most, and these are the variables that are listed there as the variables that were of interest to me that I can make something about. So you see the smoking is sitting here in the middle where low physical exercise will be of higher, low physical activity, I think it is, higher impact, and please do sleep. The smoking, these two variables have positive impact, and when you do the age adjustment, it has the opposite impact. So it's probably people who are older sleep more, and so forth. But you can do this at the data set level or do it as an individual level. And here you can look at each observation on its own and change the graphics. So for instance, I could say, you know what, I would like this to be my, from the data set, let me take that smoking that was interesting for me. Where's the blessed smoking? See smoking it was okay. Let's take this one and I'll okay. And on the y-axis, I will put the true y, not the predicted one. And you can see this is obviously there's a correlation here which you can investigate. So in this analysis where we did the causality analysis and have ability to ask questions about the observations with counterfactuals, didn't work for me now because I did my settings wrong. I don't see a directed graph, so I don't see a proper causality analysis the way I would expect it. Yeah, they've done a little bit of kind of the with and without, but it's not really the way that modern research allows for it. And actually, Microsoft has the tools with that, what Microsoft Research is developing to do this in a different way, in a much more robust and up-to-date way. As you saw, I did apply a do-y component that says, okay, let's look at the relationships, and you can see here that it didn't find too many relationships, although some of them that did find make sense. But a lot of the variables are not with high correlation, and that explains also why the logistic regression was not that strong. So this is the real story behind this data. One last word about causality analysis. That's the way to find the answer to the challenge that Albert Einstein put to us. What is the simplest model that we can still use to explain a complex situation? And causality gives us those. The causality analysis and the new do mathematics allows us to answer that. Um, I'm not 100% convinced that Microsoft should have put these tools in the responsible AI dashboard. They definitely should put it in Azure Machine Learning and add more and more around the causality analysis. It's not a question. I'm not just sure that the people who are interested in responsible AI will really know, because it's more to do the way that the tool is presented. It's to do with decision um, science. What should I do to get people to answer the marketing better and get more money out of them? And thank you very, very much for listening. I would love to hear if you agree with me, or maybe you know more about the mathematics behind this particular tool. I couldn't find it, and I would love to hear more. Maybe I was totally wrong with my hand. Thank you very much. Have a lovely day.